The goal of this puzzle is to place these 4 constellations into the grid up here so that the lines join consecutive digits, and the star is always the lowest digit in a constellation. This is going to allow us to get some information about the relative sizes of the digits. So I'm not going to type in the actual digits, but if I were to assume this digit was a 0, then these all have to be consecutive going upwards from it. These must all form a consecutive sequence, but if it goes downwards to the left, then it's going to go lower than the lowest digit, so it has to go downwards to the right and upwards to the left. This is consecutive to this one, but it can't be lower than the lowest digit in the constellation, so it has to go up. And this can't be a 0, so that has to be a 2. Similar thing over here, we get 0, 1, 2 going downwards, 1 over here, and the direction of this is fixed by the lowest digit. This one, these have to be consecutive, that's about all we can say, and this one, this has to be consecutive, but this could be either a 0 or a 2. And now we get some interesting relationships between the digits in these constellations. You can see here, we have 2 zeros that need to avoid being in the same box, and we have 2 2s that need to avoid being in the same box. I don't know for a fact that there's 0 or 2. They could be any digits between 1 and 9, but I do know that these two are for sure the same, and these two are for sure the same. And we've got exactly the same pattern over here. In order to separate these then, we have 2 options. We can either separate the zeros horizontally and the 2's vertically, or we can separate the 0's vertically and the 2's horizontally, but either way we're going to have these 2 lines crossing, forming essentially one of these 4 intersections between boxes. And the same thing over here, we can either do the zeros like this, or sorry, we can either do the zeros and the 2's like this, or we can do the zeros and the 2's like this, and those are our 2 options for that space. So that's going to allow us to start placing in potential locations for this constellation. It can't go around one of these lower ones because we have 1, 2, 3, 4 digits at least below this intersection, and it would go off the bottom of the grid, so it has to go around the upper ones. It can't go upright of this one because it would go off the grid. So if it's around here, it'll have to go down and to the right, which would place in this constellation. If it goes around this one, it can't go down and to the right, because again, that would send it off the edge of the grid. So for this one, it would have to go up and to the left, which would place in this constellation. And these are the only 2 locations this can possibly take in the grid. And maybe I'll make them different colors. I'll make this one green. Now placing this one becomes interesting because you'll notice both of these, they block off 3 of the intersections. Both of them block off the top 2. We can't place this around either of these because regardless of whether this intersection goes here or here, it's going to be taking 3 cells around that intersection like this. And neither of those are possible because there are cells that are taken up in both instances of this constellation. So we know this one has to go around one of the lower 2. If it's the gray option, it can't go around this one, so it has to go around here. And if it's the green option, it can't go around this one, so it has to go around here. And then this constellation becomes interesting. And instead of starting from here, I'll just try and start from here to show you. If I make this a 0, then this can't go downwards, because if this went downwards, then there's no way for this to be the lowest digit in the constellation. The lowest I can make this is 2, but I've got a 1 down here. So this has to go upwards. This has to be consecutive to 3, but it can't be 2, so it has to be 4. And then the only way to fill out these 2 digits so that we get the 1 and 4 connected is with a 2 and a 3. And now you can see we need this 2 and this 2 to avoid being in the same box, and this 3 and this 3 to avoid being in the same box. But if I try and separate them vertically, like so, we are guaranteed to have an intersection of boxes somewhere in here. And no matter where I place it, the best I could do, for instance, is down here and up here. But then we end up with these 3 that cannot occupy any of the intersections. They will always fight with one of the existing constellations. So I need to separate these 2's and these 3's horizontally, and once again, I cannot have this intersection, and I cannot have this intersection. So we actually know exactly how the boxes around this constellation are going to look. And now we can ask where this one goes in the grid. And the one that's quickest to rule out is if it were to go, whoops, wrong color. If I were to try and place it in here, which seems okay initially, this would coincide with the green version of the constellations. But now the problem with this is that we've got these three cells are these three cells from this constellation, and these 6 cells are these 6 cells from this constellation. And if you'll notice, both of these have digits on their constellation that are higher than them. This one has a 5 and this one has a 4, which effectively means that wherever I put 9 in this box, I would need to place a 10 on one of the other constellations. So therefore this position for the constellation does not work. And if we just look through the grid, we'll find that there's only one other place we can put it, and that is over here. So I can draw in this constellation. That's going to eliminate the possibility of this one going on this side over here. So actually we get that it is going to have to go over here, and we do indeed have the green version of the constellations rather than the gray one. This is going to allow me to start putting numbers in, so I can type in my 0, 1, 2, 3, 4, 5. And again, we don't know that these are exactly the numbers that go in these constellations, we just know relatively what they are. And in fact, now that this is a 0, and these two are in the same box, I know that this has to be 2 lower than this because they can't be the same digit. So I can start from here, 0, 1, 2, 3, 4, 5, 6, 4, 5, 6. And then this constellation over here, we can try and put it up and to the right as I have it drawn right now, but you can see that's going to clash with this constellation. So it's going to have to go down and to the left, making this intersection not here, but here. And for this one, this does look to be the correct way. So now I can place in this constellation and fill it out. And now I can start to ask, these aren't the exact numbers, obviously, because I have a 0 clashing with a 0 here, but I can start to ask what the numbers for these constellations can be relative to each other. And I'm going to start with these two and ask what these zeros can be relative to each other. And they can obviously be the same, they can be 0 apart. The constellation on the right, the most I can make this is a 9, so the most I can make this is a 3. And if I make this a 1, the best I can do is 2 greater than this constellation. The constellation on the left, most I can make this is a 9, so the best I can do here is a 4. So if this were a 1, the higher it could be would be 3 greater than this constellation. But you'll see that I can eliminate a lot of these right off the bat. If this were 1, 2, or 3 greater than this constellation, then this digit would be either the same as this, or this, which is no good. So we can rule that out right off the bat. This constellation will have a lower brightest star than this one, or equal. But if it had a lower brightest star, we can see that then if it was 1 lower, then this digit would be the same as this digit. And if it were 2 lower, this digit would be the same as this digit. So that's no good either. So in fact, they are the same. These zeros, I don't know exactly what they are, but they are identical digits. And that would allow me to, if I want, for instance, place a 0 here, place a 1, 2 pair here. I don't know what the digits are, but I could start doing that. But now let's look at this constellation and ask how it compares to the other two. Again, it could be the same. The most this can be is 9. The most this can be is 6, which would make it potentially 5 greater than these two. And still, the most this can be is 9, making this a 3, which would make the ones on the right 2 greater than this guy. We can rule out them being the same because of these two zeros. If this were greater than these, I can see that it can't be 1 greater because of this, 2 greater, 3 greater, or 4 greater, and it can't even be 5 greater because of this line. So it has to be smaller than these constellations, and the question is either 1 or 2. And it can't be 1 because then these two would be the same digit, so it must be 2 greater. And the only way I can make that happen is if I make, and the only way I can make that happen, the only way I can make this be 2 greater than anything, because the maximum this can be is a 9, is if these become 3 and this becomes 1. So that's what I'll do. I'll make that a 1 and fill out all the corresponding deductions, and I'll make these a 3. And now these are the actual digits that go into these constellations. We have no more room for freedom, and we know that these digits are actual Sudoku digits, and we can start doing regular Sudoku with them. So for instance, as we saw before, we've got a 3 and a 3 here. That's going to place a 3 there. We've got 4s and 5s, locking a 4-5 pair in here, and leaving a 1, 2, and 6 on the side. Up here, we need a 1, 2, and 9, so that's going to be the 1, 2. That's going to be the 9. Up here, we have 1, 2, 3, 4, 5, 6, 7, 8 to finish, but we have a 7 over here looking at that pair. 4s and 5s are going to go up here along with a 3. We have 4 fixed in the center box. Three into one of these two. Whoops. In this row, we need 1, 2, and 9. In this column, in fact, we need 1, 2, and 9. And in this box, we need 1, 2, 6, and 9, it looks like. So I know 6 is going to go into one of those two, along with either a 1 or a 2, but not a 9 because of that. In this row, we can actually place the 6 and the 5. This is not a 5, therefore. This is not a 3. 4 is going to go somewhere down here, along with 5. That makes this square a 9. In this box, we have left to place 1, which is going to go in one of these two, 3, which is going to go in one of these two, and 8, it looks like. And now we're starting to get to the point where we need to ask where this last constellation can possibly go into the grid. And there's only a few potential locations for it. It can't go anywhere in the top 3 boxes. I guess technically it could go here. It's unclear in the rules whether or not this counts as a crossing, but if it were to go here, that would immediately make this a 9, and then this would have to be an 8, which is impossible. So that's not where the constellation goes. If it were to go in this row, it would have to go here, but then this would have to be either a 3 or a 5, of which it can be neither. If it goes in this row, it looks like it can go either here or here, and we'll find out one of these two is correct. It can't go in this row, can't go in this row, can't go in this row, and it can go in the bottom here. That would make this a 4 or a 6. That would make this a 3, 5, or 7, but that's impossible because 3 and 7 are already taken up. So that's not correct. If it were to go here, these two digits would have to be consecutive, but we can see that's clearly impossible. There's no way to make 1 consecutive to 3, and 8 is simply too far away to reach the other ones. So in fact, we do know that the final constellation is going to go right here. And we can start placing numbers accordingly. If this was a 1, that would have to be a 2, so it's not. This is an 8, we get a 3, we get a 1. We can ask what this digit is now, and it can't be a 7, so it has to be a 9. That makes this an 8, that makes this a 9. That's not a 9. 9 goes in one of these two cells. Remaining in this row, we have 1, 2, 3, 4, 5. We have 6 and 7. Remaining in this row, we have 2 and 3, I believe. The 6, 7 get fixed, placing the 7 with the 9. The 2 and 3 get fixed by this 1 hitting that 2, making this a 1, 2, 1, 3, 2. 3 is going to go in one of these two cells now, and because of the 3, 4, 5 triple, we know which one that is. This cell, I can see we have a 4, 5 pair in the column, so this should be a right in. This should be a 6. That's going to place our 6 over here. This makes this a 2. That's our 9. Don't know why I had 6 as pencil marked in there, but this is a 1, 2 pair. In this column, we have 1, 2, and 9. This can't be 9. This can be any of them. In this box, we have 1, 2, 3, 4, 5, 6, 7, 8, it looks like. It's going to place the 8 in one of these two. It must go there. In this column, we therefore have, just resolving the 4, 5 pairs, a 6 to go. That's going to place the 6 in this box. Yes, it does. In this box, we have left 1, 2, which have to go up here in some order. 3, 4, 5, 6, 7, and 9 look to make a pair down here, and then 8 is going to go up in one of these two. In fact, it's going to go there. That places the 2, places the 1. We can knock 2 out of both of those. In this column, that 9 is going to resolve our 7, 9, and leave us with a 2. That resolves the 1, 2, resolves the 1, 9, resolves the 7, 9. We have 4 left in this box, and then we finish out this box with a 5 and a 7. And that's how to solve this puzzle.